All right, so I had to move myself up to the top corner for this video because what I want to show you is down over here, man. So in this video, we're going to answer these 3 questions. Actually, I'm not gonna do a load. You don't need to see that. You can do that. Let's just plug the thing into the other thing. So first thing, create the residual plot. So the residual plot, if you recall from the notes, is essentially the plot of all of the residuals, the residual amount being all of these distances between the points and the line itself. If you recall the purpose of this line, this is the least squared regression line. What it's trying to do is take all of these distances, square them, and then make the smallest sum of the squares that it can possibly be. So it basically takes all these, squares them, adds them all up, and the smallest this can possibly be is the amount that's made whenever this is the line that you pick. If you move this line up or down, as we saw in class, you're going to see larger numbers no matter which direction you go. So let's hide that real quick. What we're trying to do then is, rather than looking at the squares themselves, we want to look at the residual plot, which is very easy enough. We just go to the same, go to residual, show residual plot, and sure enough, underneath it, what it's done, it's taken this line and plopped it down here, made it the new sort of x-axis, and then said, okay, well, how far away each point is above the line is going to be how far the y direction is. And so you can see each of these points just sort of lines up with its corresponding point on the residual plot, right? So now we can, sorry, my thing just freaked out on. So now we can look at our residual plot. We can answer this question. Since it's seemingly random, as we saw in the notes, when it's randomly distributed, there's no clear pattern. They're evenly above and below. That's a good sign. So yes, the model is appropriate because there is no pattern, or obvious pattern, I guess we should say, left over in the residual plot. The linear model is appropriate for this data. There you go. That's all there is to it, right? I told you this video is going to be short. This one, all you got to do is plug in. So this is asking what would you predict the average January temperature to be in Mobile, Alabama, which is there, apparently. And how does it compare to the actual temperature? So you just literally calculate a residual. That's something you just plug into this equation, and then what is that supposed to be compared to it itself on the table? Is Mobile, Alabama on here? No, it's not even on here. What am I talking about? Oh, sorry. Its actual temperature is 44 degrees. So all you'd have to do is take its actual 44 degrees, subtract its whatever you get when you plug it in, and that's the residual. So I'm not going to bother to go through that. But I hope this playlist was useful. This is essentially how you do everything in the calculator. I hope you learned something. If you got any questions, leave them in the comments. Otherwise, I'll see you in class.